Alright, we're doing problem number 34 of chapter 32 of Physics for Scientists and Engineers, second edition by Randall D. Knight. And it states, the question, what value of resistor will discharge a 1 microfarad capacitor to 10% of its initial charge in 2.0 milliseconds? Alright, so I drew a little kind of a circuit, kind of asking or representing what it's asking here. Let's say we got like this RC circuit of a capacitor connected to a resistor. I put a break in the wire here to kind of look at our initial condition. So let's say we have a capacitor here that's charged and it's 1 microfarad, and so it's asking, like, as soon as we connect this circuit, okay, and you know, it starts discharging as electrons go that way, and positive protons neutralize that way. Anyways, it's asking what value of resistor here will cause this capacitor to be 10% of its initial charge in 2 milliseconds. So this is the capacity. Let's just say the voltage doesn't really matter. So let's just say it has charge Q naught. Okay. And we know for an RC circuit, for discharging an RC circuit, we can use the formula Q equals our initial condition, Q naught, times e to the negative t over RC. Of course, RC being our time constant. Well, we have a couple unknowns here. We know time, but our R is unknown, and this Q naught is really unknown. We don't know what voltage this is. We can kind of take a look at what Q really represents here. Since we're looking at 10% of its initial condition, we could kind of say that Q here happens to equal 1/10 of Q naught. Okay, so it's the same thing as saying 10% of Q. So we can actually substitute that in, and you end up with 1/10 Q naught equals Q naught e to the negative t over RC. Well, obviously we can see right here that if we have the same variable on both sides of the equation, or same unknown, we're actually going to divide out. If we just divide both sides by Q naught. And so you end up with sort of wanting to understand this whole this E part of the equation here. So we're looking for where we can get E to equal 1/10 with this exponent here. Well, one of the easiest ways to work with this exponent is we take the natural log of both sides, and that'll get rid of that E and move this down into our main area here rather than an exponent. So we could say that the natural log of 1/10 happens to equal the natural log of all of E to the exponent, and whenever you have the natural log of E to anything, the result is just the whatever the exponent was. So this would be negative t over RC. Alright. And you know, we can actually, if we want to solve for R, that's what we're looking for. Everything else we know. We know this, that's just a constant. We know T, which is our 2 milliseconds, we know C. We can just kind of multiply the both sides by R and divide both sides by this natural log thing, and you end up with R equals negative T over C times this 1 over a terrible fraction. I need to work on drawing my fractions. Times 1 over natural log of 1/10. Alright, so just throwing in some numbers so you guys get an idea of what this will look like with numbers. R equals 2 milliseconds, so that's 2, well, there's a negative in here. Okay, so negative 2 times 10 to the negative 3 seconds. And that's over 1 times 10 to the negative 6, that's microfarads, okay, times this natural log of 1/10. Okay, you just crunch all that in your calculator and you end up with R being equal to, I rounded it a little bit here because we're not that precise, 870 ohms. Just as simple as that. Alright, hope that answered any questions for anybody. And that's that problem.